All right, so I'm going to point out this one has oxygens. You probably knew that. That is going to make our process just a little bit longer, but don't let that scare you off. It still starts the same way by finding oxidation numbers of our individual elements. And I'm going to go ahead and start with the easy ones, the ones that are labeled, the ones that are 0, and then these simple 2-element ones. Oxygen gets what it wants, nitrogen deals with a +2 because of it. And over here, oxygen gets what it wants, but these need to add up to -1. So with 2 -2s, that's -4. So N is going to be a +3 here. So now thinking about how these are changing, our iodine looks like it's being oxidized, +1 to, or -1 to 0. There does mean it is going up. And yes, our nitrogen is going down. It's being reduced because it's going from +3 to +2. So we're going to separate all of that iodine and nitrogen stuff. And if you notice, oxygen is not being oxidized or reduced. That doesn't mean it doesn't belong in either. That means that it doesn't have to get separated from each other when we're separating the iodine and nitrogen stuff. So the iodine reaction is going to be pretty much what you would expect. We're going to have that I -1 turning into I2. And then the nitrogen half reaction, the reduction half reaction with the nitrogen in it, is going to have that NO2 -1 turning into NO. So if it's not being oxidized or reduced, it can just kind of stay with whatever it's with. And especially since it's oxygen, we've got a way to handle oxygen in these reactions. So now that we've got these separated, step 2 is to balance our special elements. We're not going to worry about that oxygen yet. So our iodine half reaction, we need to balance because we've got 2 iodines on the product side. So we need to put a 2 up here to get 2 on the reactant side. And our N's are equal, so we don't have to use any coefficients there. Step number 3 is to balance our oxygens by adding H2Os. We need to make sure that we always add our H2Os to the side that needs more oxygen. That's the whole idea. We're trying to balance them and get them equal. So because the reactant side had 2 oxygens and the product side just has 1, then I'm going to add 1 more oxygen in the form of 1 H2O. And as soon as you add an H2O, because we were balancing oxygens but some hydrogens came with it, we are going to have to go to the opposite side of the same reaction and add in twice as many H+1s. Because that's always going to be H2O, then we're always going to be having to add twice as many H pluses because they come separately instead of in pairs like an H2O. And it's also important to remember that those are +1 charge H's, not just H's on their own. So this is that point where we can check and make sure all of our atoms are balanced. 2 I's, 2 I's. 2 H's, 2 H's, 1 N, and 2 O's, 1, 2. All of our atoms are balanced, so we are ready to move on to the next step, which is our electron step. So we're going to be adding electrons to the product side of our oxidation, reactant side of reduction. And if we look at the reactant side up here, that's a -2 charge. Have to remember that 2 coefficient here. It's easy to forget because it's so far away from that charge. But -2 means that this is going to need 2 electrons here on the product side. On our reduction half reaction, we're trying to get the reactant side to add up to 0 like the product side is. We're already starting off with a -1 and 2 +1s. So if I have +2 and -1, then currently my reactant side is at a +1. And if I want to bring it down to 0, then I'm only going to need 1 electron. Just like the other coefficients, you don't technically need to write this one, but it's so easy to forget. those electrons or to lose them since they're so tiny. This is one of those rare times when I do write that optional 1. And so here we see the first time our electrons aren't 2. It's not every time, I swear. So our charges are balanced, our atoms are balanced. Now we want to start adding these back together and squishing them back together, but we've got to make sure that our electrons are equal, which in this situation they are not. So we need to multiply by some kind of number to make them equal. That is just going to need to happen to this reduction half reaction. Everything in here needs to get multiplied by 2 in order to equal out our number of electrons. So that means that we're going to have 2 electrons. We're going to have 4 H pluses, 2 NO2s, 2 NOs, and 2 H2Os. And as soon as we can confirm that, yes, those electrons are equal and opposite, then we are ready to cancel them out. You can look through and make sure there's nothing else that's the same on both sides, and here there isn't. So now we can just add all of this stuff up onto the reactant side and all of this stuff up together onto the product side. Just each of those things separated by a plus sign. So if we do that real quick, just bringing everything down, that gets us our final overall equation. So hopefully those oxygens aren't too difficult. It does add a couple more little steps, and it's more stuff to count and balance when you're adding those electrons in. But just take it slowly and make sure you're paying attention, and it's not that bad.